Today we will be continuing with coordinate geometry, and last class we would have done finding the midpoint of a line, the gradient of a line, the y-intercept of a line, the x-intercept of a line, the length of a line, the format for the equation of a line, which is y is equal to mx plus c, and several things in between. So what we're going to continue today is finding the properties for parallel and perpendicular lines. Right, so a parallel line or parallel lines are actually lines that are opposite each other, but they don't touch each other. So when you hear something is parallel, they have the same direction, meaning they are slanted in the same direction, and they are a distance away from each other, but they never touch. Anytime two lines touch, then they are not parallel lines. So we have an example of two parallel lines here. Now for parallel lines, the gradients are equal to each other because, as I rightfully said just now, they have the same they have the same distance in their orientation. So meaning they have the same slope, they have the same gradient. So if this line is y is equal to m1x plus c, then this line is equal to y is equal to m2x plus c. And we know that the gradients are equal to each other, so m1 is equal to m2. So for example, again, we have a line y minus 7x is equal to 9. And we have another line, 2y is equal to 14x minus 5. How do we know if these two lines are parallel? We need to find out if they have the same gradients. And in order for us to find out if they have the same gradients, we need to put them in the proper equation of the line format, which is y is equal to mx plus c. So we are going to make y the subject of the formula for this, y minus 7x minus 9. All we will have to do is add 7x on both sides, so we'll end up with 7x minus 9, because we're adding it on both sides, right? So it kind of looks like this, minus 9 at 7x, but I'm just going to put the x in front as well, the x2. So it will be y is equal to mx plus c. So here we know that our gradient is equal to 7. Now let's do the other line. 2y is equal to 14x minus 5. So this is 2y. So we can divide the equation by 2. So this will be 14x minus 5 all over 2. And we could break it down. 14, so let me just put it separately, over 2 over 2. Remember, you have to divide it by each term. So 14 divided by 2 is 7x minus 2.5 or 2.5 or 5 over 2, anyone is fine. And we see that m is also 7 here. Therefore, our two lines are parallel. So just to recap, parallel lines have the same gradients. Now for perpendicular lines, when you hear a line is perpendicular to another line, right, those lines are actually going to touch each other. So perpendicular lines are lines that look like this. It doesn't have to be slanted like this, but one is standing on the other one. They intersect at some point, right?
One says 90 degrees.
Yeah, they will form 90 degrees. So now for perpendicular lines, as with the gradients of parallel lines, they are equal to each other. For perpendicular lines now, when the product of the gradients will give you -1. So y is equal to m1x plus c. And this line is y is equal to m2x plus c. When I multiply the two gradients, I will get the answer as -1. So if I do an example and I say 3x plus 2y is equal to 7 and 3y minus 2x is equal to 5. So we have equations of the line here, but they are not in the correct format for us to identify what is the gradient, what is the y-intercept, etc. So what we have to do is put it into that form. So we'll take the first one, which is 3x plus 2y is equal to 7. Remember, the form is y is equal to mx plus c. So the first thing I'll have to move is this, because remember, I'm making y the subject of the formula, so we remove the things around y. So we'll end up with 2y is equal to, that will be -3x plus 7. Now we'll have to remove the 2 by dividing by each term, so -3x over 2 plus 7 over 2. So we can leave it as improper because there's nothing really for us to simplify here. So now we know our gradient is equal to -3 over 2 for this one. So we do the second one, 3y minus 2x equals to 5. What we're going to move is the -2x. So 3y is equal to 2x plus 5. And then we divide by 3, 2 to 8x plus 5 over 3. And we know our gradient here is m1, m2 is equal to 2/3. Now for me to know if they are perpendicular, I multiply them. So m1, m2 should be equal to -1. So I have -3 over 2 by 2 over 3. And I see when I cancel them, I do get -1. So therefore, the two lines are actually perpendicular. And that's how simple it is really and truly. You know one gradient, you know the other gradient, you multiply them to get -1. If you get -1, they are perpendicular. If you don't get -1, they are not perpendicular. Identify whether the following pairs of lines are parallel, perpendicular, or neither. So the first thing we want to remember to do is get them in the equation of the line format. Y is equal to mx plus c. So that means we have to make y the subject of the formula. So for this one, y is equal to 7x minus 2. It's already in the format, and we know our m, which is our gradient, is equal to 7. This one, y minus 7x equals to 5 is not in the format. So we need to remove the -7. So of course it's going to be 7x plus 5, and therefore m is also equal to 7. So our lines, the lines are parallel because the gradients are equal to each other. Okay, so for the second one, again, not any format, so we would put it in a format. Remember, the format is y is equal to mx plus c. So we remove the 4x, so that's going to be 2y is equal to negative 4x. I'm putting the x in front because I want the x has to be in front, right? Negative 4x plus the 5. And then we divide each term by 2. Y is equal to negative 4x over 2 plus 5 over 2. Hence giving us y is equal to negative 2x plus 5 over 2. And our m is equal to -2. So we do the second one, y minus a half x is equal to 4. Again, put it in the format. So we know we have to move the negative a half x. So we'll end up with y is equal to positive a half x plus 4. And it's already in the form, so m is equal to a half. So we know that they are not equal to each other, so we know that they are not parallel, right? So we could say the lines are not parallel. So let's find out if they are perpendicular. In order to find out if they are perpendicular, we could say M1, we could call this M1 and M2, by M2 is equal to -2 by a half, and that gives us -1. So therefore, the lines are perpendicular. An additional question, we have these two equations. To find out if they are parallel or perpendicular, we know that they are not uniform. So we took this one here, we put it in a form, and we got our gradient to be 0.4 or 2/5. We took the second one, put it in second equation, put it in a form, getting m is equal to 0.5 or 2/1. Therefore, our gradients are equal to each other, so the lines are parallel. So we are going to continue to go on to points of intersection now. And a point of intersection is where at least two lines or two curves, or a line and a curve, meet each other at a coordinate. So I'm going to put in two lines. The first line I'm putting in is y is equal to 2, and then the second line I'm putting in is x is equal to 3. Now, where's the line y is equal to 2? Is it a horizontal line or a vertical line? Horizontal is this way, vertical is this way. So y equal to 2 is 1 or 2, horizontal or vertical or horizontal?
2.
What's that?
Y equals 2.
Yes.
1.
So y equals to 2 is at this point here, and therefore we go across. So it's horizontal. You can't go up on the y-axis. You can only go across. So that should be a straight line. So this is horizontal. X is equal to 3. You look for 3 on the x-axis and you go standing up now. So what is the point of intersection? The coordinates. What's the coordinate for where they intersected? So it's at this point, right? What's the coordinate there?
3 and 2.
What's that?
3 and 2.
0 and 2?
3 and 2.
3, 2. So we take the x first, which is 3, and then the y, which is 2. Awesome, and that's our point of intersection there. If my line is x is equal to -1, y is equal to -3. So I'm putting in what x is equal to -1 is, so I look for -1 and I make a horizontal, a vertical line. So my x lines are always vertical. Right, and y is equal to -3. I look for y at -3 and I make my horizontal line. So we go across. Anytime we pick in a number from the y-axis, we go across. Anytime we pick in a number from the x-axis, we go up. What is the points of intersection for these two? So it's here. What's the coordinate for the point of intersection? Tiffany?
-1, -3.
-1, -3. Very good. We go to our x first, we get our y. -1, -3. Right, so that's points of intersection, really and truly. We could do it with curves as well. We could do it with full functions. So let's say we have a line y is equal to 3x minus 2 and y is equal to 4. We want to find the point of intersection using a graph, right? So how to plot this line y is equal to 3x minus 2? How do we plot this line? What do we have to do?
Find the gradient.
We already know what's the gradient. The gradient is 3. The y-intercept c is equal to -2. So from this, we know that our line is cutting the y-axis that way. At what point?
-2.
-2. So we know our line has to be passing through this point because this is the y-intercept. But how do we plot a line? You remember how to graph a line, a function? What do we have to do?
Find the coordinates.
So we get domain values, we plug it in to get the y values. Good. So we have y is equal to 3x minus 2. What are some values we could use?
-2.
As what? Y or x?
As x.
As x. So we're going to try for -2. That means y will be equal to 3 by -2 minus 2. That's -6 minus 2. That's -8. So your first coordinate was -2 minus 8. So that's all the way down here. So let's try another point. Everyone pull a point quickly. Let's draw this line, please.
What about 2?
All right, so 3 by 2 minus 2. So that's 6 minus 2, that's 4. So my second coordinate is 2 and 4. So 2 and 4. Right, so what can I do now that I have two nice far coordinates?
Connect them.
Connect them, nice. And that's our line right there. So it's actually going to be like, so it's not drawn to scale, right? So I'm going to switch over some of my coordinates. So this here is -2, -8. And this point here will be 2. Right? So it's not drawing to scale. That's why if it was on a graph, we would have gotten it, right? So, and label it y is equal to 3x minus 2. So we have the first one in. Where's our y is equal to 4 line? So we look for 4 on the y-axis
On top,
here. And do we go across or do we go up?
across.
Across at this point. What's our points of intersection?
2 and 4.
2 and 4. Yeah. Do we have any questions there?
No.
Let's try a second one. So we have 2y plus 3x equals to 5 and x is equal to 3. We're trying to find the points of intersection, so we have to draw the graph for both of them. How to plot the first one? Two y plus 3x. 2y plus 3x equals to 5.
It's just on for the one above that we did previously. Was it not -2 and -8?
Yes.
Then that 8 is horizontal minus on the never mind.
Right. So how do we go about plotting the first function? 2y plus 3x is equal to 5.
We find the domain.
All right, so we're gonna plug in some points. 1, 2, 3, 4, 5, 6. So remember, these are not drawn to scale, so it won't be exact. So what points are you going to choose? Let's go. Can I have a point, please?
-3.
Oh, -3. So wherever we see x, we substitute for -3. So 2y. The easier thing for you to do will be to make y the subject of the formula. So you wouldn't have to, so you could do it anyway. You could make y the subject of the formula and then substitute it, or you could substitute it straight into this once you could work it out. So 2y plus 3 by, what did you say?
-3.
-3 equals to 5. We'll end up with 2y minus 9 is equal to 5. And we'll end up with 2y is equal to 9 plus 5, which is 14. And y is equal to 14 divided by 2, which is 7. So our coordinate is -3, 7, which is here. All right, and then our next line is, sorry, we need to do our next coordinate. So what other number we could use?
-5.
So -5. Two y plus 3 by -5 equals to 5. That's 2y minus 15 is equal to 5. 2y is equal to 10 plus 5, which is 15. And y is equal to 7.5. 9 -15 plus, sorry, this is 20. And so that will be equal to 10. So our coordinate is -5, 10. So that'll be somewhere up here, but we don't want that. We want something on the other side of the graph so we could connect, making sure we cross the axis. So we could try a positive number. Right? So 4, that's +12. That will be -7. That will be -3.5. So 4 and -3.5. So 4 minus 3.5 somewhere here. In between here. Any questions? So always try to have it on the two sides opposite so you could cross the axis, right? So it's kind of looking like the y-intercept is 1 just from the graph. It looks like that. Let me see if it's actually that. So we know we could get that if we put a line in the equation of the line formats. So that's going to be 2y is equal to -3x is equal to, so it's actually 1.5, yeah. Y is equal to -3/2x. At 5/2. Y is equal to -1.5x plus 2.5. It's actually 2.5. So this is a like bad sketch. So the y-intercept should actually be somewhere here, right? But again, remember, it's not drawn to scale. So yeah, we have our first line. Now we need to put x is equal to 3. X is equal to 3. We look for 3 on the x-axis, which is here, and we go up or down. Up and down or across, which one?
Y is equal to how much? Oh, x is equal to 3. Down.
So we make a vertical line. And our points of intersection average is where?
-2.5. No, 3 and -2.5.
So 3 and it looks like 3 and -2.5. Yeah. You know, from our graph, it could be wrong, right? Because our graph is a little sketchy, literally, right? So let me see what they have as their answer in the book. Part 2. B. 9. X is equal to 3. B part 2. They have it as 3 -2, right? So we close, right? 3 -2. Everybody understand? So good job on plotting your graphs. Pick a far point on the left, a far point on the right, cross your axis. You can identify your y-intercept from where the line cuts the x-axis, where the line cuts the y-axis. You can identify your points of intersection from where the two lines cross each other.
Let's get this roll back up just a little bit. Please.
So I would recommend you grabbing graph paper and plotting, doing the actual graphs for these on graph paper. That's the only way you're going to see actual answers. Correct and precise answers.
Miss, you work out the y-intercept there, that one pretty much clear.
No, I didn't. I was just showing you how to identify where your y-intercept is.
Oh, I just wanted to see if the figure on the graph was correct or precise.
Where is that? For which one?
The for the intercept, the y-intercept.
No, I was saying on our graph, the y-intercept could have been +1. Yeah,
But wouldn't you get the same answer if you had to work it out?
so
No, disregard the inaccurate graph. It's a woman in general.
yeah, if you work it out and you plot the graph, you will get the same answer. But I will not get the same answer because my graph is not to scale. So you see how the y-intercept here is 2.5, but my y-intercept is 1 because my graph scale is off. But if you, that is why I said, go to your graph book now and do the actual graph. And when you plot these two things, you will see on your graph, your y-intercept is 2.5. When you do this in your graph, you will get it matching back this. Everybody understanding that, right?
Yeah.
So the actual answer for this, for the point of intersection, is actually 3, -2. But because my graph scale is off, I have it a little off as well. You're following me, right?
Yes, please.
Right, so if we were to solve a simultaneous equation now using the graphical method, what would we do again? So a simultaneous equation by graph is the same thing. So let me actually put on the graph, right? So we'll have it more accurate. So we have 2x plus 5y equals to 18, and 3x minus 2y is equal to -11. So again, if we're going to solve this for the point of intersection on a graph, what do we have to do? Huh?
Get the coordinates.
So we're gonna plot the two graphs and see where they intersect, right? Same thing. So let's do the first one. So the first one is 2x plus 5y is equal to 18. Let's find 2 points to give us our line. What's the first value we're going to use for our x? Use one from across here. So I'm going to use like 4.
Yes.
2 by 4 add 5y is equal to 18. Please, you'll have to know how to solve these things. 5y is equal to 18 minus 8, because this is 8. So it's going to be 18 minus 8. And y is equal to 18 minus 8 is 10. So 10 divided by 5, which is 2. So our coordinate is 4, 2. Yeah? So right here, right? Everybody got that? Any questions? All right. So we're doing another point. I'm going to choose a point from, sorry, 4, 2 is across here. Why you're not following the question or you're lost? Which one? Because nobody told me I plotted the point wrong.
Yes, I was right. No, the working.
So follow the question, right? You can write down the working after. Follow the question. So 4, 2 So what are we going to choose now for? So we chose 4. Now let's try -4, right? So 2 by -4 add 5y. So our trick we're using is to take a positive and a negative number, right? So we'll have it on the 2 sides. So we'll end up with 5y is equal to 18. This is -8. So it's going to be add 8. And we'll end up with 5y is equal to 26 over, 26. And then y is equal to 26 over 5, which is giving me 5.2. So our coordinate is -4, 5.2. So that's going to be -4 and 5.2. So right after 5. Right after -5. Now that we have our 2 points, we connect them. And we label our line y. (2x plus 5y is equal to 18). So second line now, 3x minus 2y is equal to -11. Which number will we choose?
Let's say to get to extremes, we use a positive number and a negative number, right?
Positive and negative numbers, so we get them on both
Okay.
sides. Yeah. All right, so what will we try for this one here? The second one. X coordinate.
Use 5.
So 3 by 5 minus 2y is equal to -11. That's -2y is equal to -11 minus 15. -2y is equal to -26. Y is equal to -26 over -2, which gives me 13. So my coordinate is 5, 13. Yeah?
Yeah.
So 5, 7, 8, 7, 8, 9, 10, 11, 13.
12, 13.
For someone to get to 13. So 5, 13. So we're up here. Here. All right, can I have a next one?
-4.
So -4, 3 by -4. I think I want something smaller. -2. I'm not trying to go all the way down there. Minus 2y is equal to -11. That's -2y is equal to -11. This is -6, so this is going to be +6. -2y, that's going to be -5. Y is equal to -5 over -2. If you don't know how to solve if you don't know how to solve linear equations, you will be in deep waters because you'll know how to plug in, but you wouldn't know how to solve. So 2.5. So our coordinate is -2 and 2.5. So -2 and 2.5. So here. -2 and 2.5. Okay, something isn't really working out, you know. Let me check this over. 2x plus 5y is equal to 18. 2x plus 5y is equal to 18. 2 by 4 plus 5y is equal to 18. 8, 5y is equal to 18 minus 8. y is equal to 10 over 5, which is equal to 2. So our coordinate is 4, 2, which we plotted. Then we did another coordinate, -4, 2 by -4 is -8. 5y is equal to 18. That will give us 5y is equal to, this is -8, so it's going to be +8. 18 plus 8 is 26. 26 divided by 5 is 5.2. So our coordinate was -4. All right. See, you're not helping our sister out because it was -4. 5.2, and I went down to -5.2. -4. 5.2 is up here. Thanks a lot for the help, y'all. You're paying a lot of attention. Right, so this is where the point is going to, so it's from here to here. And the other point is from here to here. How did I know they wasn't working out? Because they weren't intersecting, and they should have been intersecting. All right. So, and this one is 3x minus 2y is equal to -11. So what's our answer for our simultaneous equation?
X minus 2y equals -11.
Huh?
That's the answer, or that is the lines.
This is the 2 lines, mom. What's the answer for our points of intersection for the 2 equations?
Looking like 4, 1.
This is like -1.2 or something. No. Yeah. -1.2 and 4.
All right, so about -1.2 and 4. So the actual answer is -1 and 4, right? The actual answer. So that, let me probably draw this over. So even if your line a little off, you see, my line was a little off. Seeing it now? So we have to be very specific when you're drawing a line. So this is our point of intersection, which is always x before y, so -1, 4. Tiffany, you're quiet. What's happening?
Nothing.
Nothing
Fine,
is
fine.
happening.
No, I just getting everything in.
What do you mean by getting everything in? In where?
Understanding it.
So you understand what's happening here?
Yeah.
Everybody else understanding?
Yeah.
Yes.
All right, so last thing before we go, we're going to draw a quadratic equation, which is the same thing, yeah? Same thing, same thing. Tell me when you all are ready. Graphing a quadratic equation
Yes, can you go back up one more time?
So when we graph a quadratic equation, we would also know how to find the intersecting points from a quadratic equation on a line, etc. So it's the same concept. Let's say we have an equation that is x squared. Draw the following graph of the function x squared plus 2x minus 3 and they said the domain. So they gave you the domain because you need a range of values. You can't just use one on the left, one on the right, because that will give you a straight line. But a quadratic is actually a curve. So we will need several values to connect to form that curve. So your domain is going to range, x is going to be greater than or equal to -5 and less than or equal to 3. So what are the domain values? X such that x is equal to what? What are the domain values according to this range here? X is greater than or equal to -5, but less than or equal to 3. So what's the first value in this range?
It's just how you get this inequality.
They gave you the domain.
Oh, okay.
Yeah. What's the first value in the domain?
-5.
-5, then
-4.
then
-3. -2. -1 and 0. 1, 2, 3.
right? So that's what the range reads. So we remember how to do that, right? X is greater than or equal to, because we have the equal to, we included these two. If it was just greater than and less than, our numbers would have started from 4 and ended at 2. Any questions there?
No.
Right, so therefore we go and substitute each value into our function to get our ordered pairs, aka our coordinates. So the first thing we're substituting is -5. So -5 squared plus 2y, we have another x, so -5 minus 3. You'll go ahead and work out the answers to me, please. -4 squared. By the time I'm finished writing down all, I'm coming back for answers. 2 by -4 minus 3, -3 squared plus 2 by -3 minus 3, -2 squared plus 2 by -3, 2 by -2 minus 3, -1 squared plus 2 by -1 minus 3, 0 squared plus 2 by 0 minus 3, 1 squared plus 2 by 1 minus 3, 2 squared plus 2 by 2 minus 3, 3 squared plus 3 by 3 minus 3. Setting up my graph, scale it according to how they told me to scale it. I am just going to stick with 1 to 1. And I know the x values I should have is up to -5 and 3, because that's the only x values that I would have used, right? So it's going to be I'm going to use 2 to 1, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. And then I'll wait to see where my y values carry me. So what's the answer for the first one? What's the answer for the first one? What's the answer? Yeah. You can't tell me that I wrote all of this, set up a graph, and you all still haven't worked out the answers for the first few. 12. So my ordered pair is -5 and 12. What's the answer for the second one?
5.
5. Someone else, what's the answer for the third one? Tiffany, what's the answer for the third one? So we would have substituted the domain into our function, giving us our y values. So now it's time for us to plot our points on the graph. So the first one is -5 on the x, 12 on the y. So that's up here. Yeah, we're going through the writing. But you could just put your point, right? It's just hard for me to put points, but yeah. Next one is -4, 5. So that's here. Next one is -3, 0. So that's here. -2, -3. So that's here. -1, 4. -1, -4. So that's here.
So how it have the last one have 3.
Had what?
3. 3 squared plus 3 by 3 minus 3. And it's
9 plus 9 is 18. 18 minus 3 is 15.
supposed to be 2 by 3.
What?
2 by 3.
Where?
Last year.
Oh, okay. 9 plus 6, 14.
5 is 6.
So 9 plus 6 is 15. 15 minus 3 is 12. All right, thank you. Where am I? -1, -4. 0, -3. 1, 0. 2, 5. 3, 12. All right, now that we have that, we can connect our points. So for a straight line, we use a ruler. For a quadratic, we just go from point to point and we take our time. No ruler, freehand. Because it's a curve, so it's curving right here. It's so nice and beautiful, right? Yeah, and that's our graph of a quadratic equation. So if I add in another one, y is equal to 5. Where would that line go?
Between the 6 and 4
points.
in the y-axis.
So nice. And what are our points of intersection? What's the first coordinates for the points of intersection? Because apparently there are more than one.
-4 and 5.
-4 and 5. What's our second one?
2 and 4.
2 and 5.
2 and 5, sorry. Yeah.
What's the y-intercept?
Of that line or the original line?
The y-intercept of the
0 and 5.
the y-intercept of the curve.
-3.
-3.
Or 0, 0.
0 minus
Yeah.
3.
0, yeah.
All right, what's the y-intercept of the straight line?
0 and 5.
0, 5. What is the x-intercept of the curve?
There are 2 coordinates. That's
Mhm.
0 and -3.
Yeah. And 1 and
No, sorry.
2 and 1.
-3 and 0.
-3 and 0. Always remember, every time you speak a point, ask yourself, did I call the x first or did I call the y first? So -3, 0 and
1 and 0.
1, 0. Yeah? So the x-intercept cuts the x-axis, the y-intercept cuts the y-axis. We have a y-intercept here. We don't have an x-intercept for this line because it doesn't cut the x-axis. Yeah?
This is a function because I had 2x and 1y.
Correct? What type of function was it?
Many to 1.
Many to 1. Of curve, of line, straight line. So we have a follow-up question here. And this is how a question could come in an exam. Solve the graph x² plus 2x minus 3 is equal to 2. Is this part of the question familiar to you?
Yeah. It's
What
a
is it?
quadratic. A quadratic now.
Not just a quadratic, but how familiar is it to you?
Isn't this the one we have to substitute the numbers into the function?
Yes, but how familiar is this quadratic equation to you?
Like linear or non-linear?
No. Is it familiar? You all know what familiar means?
Yeah, and looking, yeah. That's where you're finding the A, B, and C and that.
No, that is a factorizing. Don't get it.
Didn't we just do this?
Exactly. We just did it. It's right here. That's what I mean by familiar.
A function.
No. Familiar.
No, it's a function.
It's not just a function, it is the function we just worked out. X² plus 2x minus 3. Yes?
This
Yeah.
would be x² plus 2x minus
No.
1,
No.
plus 1, sorry.
No. This is where, again, they trick you all and they try to intimidate you all. Right? Don't do anything like that. Remember, you are solving the graph. That means you have to put it on the graph and actually solve it, right? So you have the graph of x squared plus 2x minus 3. If they say it's equal to -2, what does that tell us?
The whole line will be equal to the -2. Or
So what do we do with this -2 here? What's the original way of writing this function? This, right? You're with me, right? What can I replace this as? What's another thing? What's another way you can see this on it in an exam? This part here.
minus f minus 2.
Minus
So,
F?
no, it's the f minus 2. Minus 2 being the x value. No?
D5. X will be, no, y is 5.
So we're not talking about the y is equal to 5 part. What is another way to write this? When we now started functions, we learned a bunch of different ways you could represent a function. This was one. What's another way?
G of f of g.
I don't.
But all lab.
What's another way we could write a function here quickly? What's another way we could write a function? Instead of this, what can we write? Nobody in finding the way yet?
Is it
Huh?
gx?
You could put
Is it-
g of x. What is the most common way to write a function?
f of x.
F of x is one of them. What's another one?
F inverse.
No. To write a function. We have f of x, we have this. What is another common way? We've been doing it whole
G of-
night.
G.
No, we've been doing it whole night. We've been doing it following classes. What can a function be equal to?
Is it y equal to x?
Y. Yes? Y is always well, this is the most common way somebody will give you a function. Y is equal to x squared. Well, y is equal to the function. Yeah? So if they say the function is equal to -2, what is that telling you here? That this is equal to what? So if I can write this as x squared plus 2x minus 3 is equal to what? What can I write this as? This could be equal to what?
So
As a-
y,
Y. So what does -2, what does this tell you about
Y
this?
equal minus 2.
Y is equal to -2, and what does that tell you? Graphically, what does that tell you? What can you do? So we know, therefore, y is equal to -2, and what can we do with this?
find the domain.
What do we mean? Y
No,
is
the-
equal to -2.
Can we plot it?
We
So
can't
this-
put the line.
Or the line, make the line equals to negative, the y line equal -2.
Where would we put that line?
0, 2, so that would be vertical.
Where would we put the y is equal to -2 line?
By 2,
And by -2.
-2.
There's no plotting, right? Remember, y lines and x lines, we just draw it vertical or horizontal. Yeah?
Yeah.
And what do we do to get the answer? But this is equal to -2. This function is equal to -2, and we have the two lines. We have the curve and we have the straight line. How to get the answer? What's our answers?
Where it cross the curve.
Where they intersect. Same thing, I asked in a different way. Yeah? You're with me? All I asked you to do was find the points of intersection in a different way. And I put the two graphs equal to each other. Y is equal to x squared plus 2x minus 3, and y is equal to -2. Seeing that y is, remember this, seeing that y is equal to -2 and y is equal to x squared plus 2x minus 3, both of them are equal to each other. This was simultaneous equations, right? So -2 is equal to x squared plus 2x minus 3. So therefore you plot this line and you plot this line and you find the points of intersection. What's the point of intersection? First one.
Let's get over that explanation again. The one we had the
Give me the points of intersection. Points of intersection. One thing at a time.
-2 and I don't know if that's -2 point.
-2 and
Negative.
that's not -2. What's the points of intersection, y'all?
-2.5
That's
minus
Yeah, it's now a circle just now.
-2,
-2
yeah, -2.5 and
-2.
-2.
What's the next one?
1 and -2.
-2 and 1.
What? Always
Oh,
a crystal. X first and then Y, crystal. X first and then Y. X
0.
first and then Y.
End up like 0.4 and 2.
Yeah, so it's right before 0.5. Remember, 1 is here. So this is 0.5, right below 0.5. So 0.4 and what?
-2.
-2. Yeah? Always remember X then Y. So yeah, this is, and this, they love to do it like this, y'all? And I sure y'all will watch this and be like, what? I don't know what this is about. All they tell you to do is solve the graph. So they say solve the graph. Right? And more than likely, or you would already have the curve. So you will have this part, x squared plus 2x minus 3, and they will just tell you solve the graph, and they will put the graph and put it equal to some random number. So what you have to do is remember that you pay attention, make sure it's the same thing that you would have had from before. And then remember that this is y. So all you have to do is go and plot y is equal to whatever point they give you. It could be y is equal to 10, you go and make a y is equal to 10 line. Y is equal to 2, you go to make your y is equal to 2 line. Y is equal to -2, make your y is equal to -2 line. And just go to the points where the graph and the line intersect, and you would have solved your equation. So points of intersection for the line and the graph is equal to where they intersect. And you would have solved it. X is equal to negative, and the same way we would have had two answers. X is equal to -2 across here. X is equal to -2.5 and y is equal to -2, and x is equal to 0.4 and y is equal to -2. So what I was saying is, remember simultaneous equations? When we were doing solving simultaneous equations using the method of substitution, when you have y is equal to -2 and y is equal to x squared plus 2x minus 3. And this was equation 1 and equation 2, and you substituted 1 into 2 or 2 into 1. And you made both of them equal to each other, so -2, because wherever you see y, you replace it with -2, right? Because y is equal to -2. So -2 is equal to x squared plus 2x minus 3. You could work this out via factorizing and you'll get these. But they wanted you to solve it graphically. Yeah?
Yeah.
So I'm just showing you that y is equal to 2, y is equal to -2, and y is equal to x squared plus 2x minus 3 is the same thing like this, which is what we have here, right? From stuff we would have learned previously. So you're supposed to be able to identify this, that y is equal to this and y is equal to this, two different functions. Plot the two lines, find the points of intersection. Any questions there?
No.
8 minutes past 8. I don't even understand. I don't even understand. Class was supposed to finish half 7. But you all know how it is. We are grinding. It is the almost last month. We just go. More than likely, you all can join my Saturday classes. I will be doing Saturday classes with my Form 4s and Form 5s. Within the last month of class, I usually join the adults and the Form 5s together.
Yes, I've seen articles where they wanna postpone the exams for 3 weeks. Is this true?
So I am not sure if they will postpone it or not, but what we do is prepare as though there is no postponing, right? And plan as though there is no postponing. So regardless of if it does or if it doesn't, we will still be prepared. Yeah?
Yeah.
They would have said it before and they didn't. They would have said it before and they did. I really don't think that it will be postponing. I don't know what would be the reason to postpone, but we'll see how it goes. But we are planning and preparing for May the 11th until things are confirmed with regards to a change or not.
One more question is, it doesn't necessarily have to come in the quadratic form once it matches the function that you did before, which you put before. That's
Yes,
very
once it matches the function that you did before. Because that will be the points that's basically for them to intersect. So all we need to remember to do is draw the line for this part. This is the part that you have to remember. Draw the line for that, and that will always be y is equal to whatever the number is here. Yeah?
Yeah.
And once you draw that line, they will intersect, and you will get your two values. Oh yeah, I was saying one more thing. So this is our graph. Does it have a maximum?
Yeah, the maximum.